Good morning, one and all. Today I will discuss the demodulation or detection of SSB-SC signal. Demodulation or detection of SSB-SC signal. You know, there are two types of detection technique. Number one, the coherent or synchronous detection, and number two, non-coherent or asynchronous detection. And demodulation and detection are the same thing. You people, everybody knows. Now, as far as coherent detection or demodulation is concerned, one carrier involvement is mandatory, whose phase and frequency are exactly same which we used the carrier signal at the time of modulation process. That is the synchronous or coherent detection. But in case of non-coherent or asynchronous detection, there is no involvement of the carrier. We use different techniques like square law detection, envelope detection, or rectifier detection for demodulating the message or baseband signal. Now, the baseband or modulating signal, we know the baseband signal is represented in terms of small m t. The baseband or modulating signal mt can be recovered from the SSB-SC modulated wave by using synchronous detection technique. The process of synchronous detection involves multiplication of the received SSB-SC modulated wave with a locally generated carrier, which we have already discussed a few minutes back. Now, just go through the block diagram in the very top portion of this slide. Here, from the very leftmost portion, you see the incoming SSB-SC signal. That means SSB-SC modulated wave as an input of a product modulator. And the lower portion, one carrier signal, that is the cos omega ct or cos 2 pi fct. That is the two input of a product modulator. And as a result, we are getting the signal E suffix d t. Okay. Now, the output of the product modulator is just a input of a low pass filter. Now, what is the function of a low pass filter? Here we know we are going to detect or demodulate the SSB-SC signal. Demodulate or detect. Now we know our main intention is to recover the message signal or baseband signal, which are in generally is a low pass, low frequency signal. That is why a low pass filter is used for here. And at the output of the low pass filter, the original baseband signal empty is recovered. It is very clear from this block diagram that the SSB-SC modulated wave followed by a carrier signal, the input of a product modulator, and the output of the product modulator is the input of a low pass filter, and the output of a low pass filter is the original message information. Now, this block diagram may be represented in terms of mathematical background. Now, here the output of the product modulator E suffix dt. Clear? We ultimately achieve the E suffix dt. Then we will use the low pass filter. Now, E dt equal to ST SSB into cos omega ct. We can write E dt equal to ST SSB, that is the SSB SC modulated wave into a carrier cos omega ct. Okay. Now we know, considering the lower sideband and upper sideband, the SSB-SC modulated wave may be represented as cos omega c plus omega s t or cos omega c minus omega st, that is considering upper and lower sideband. The SSB-SC modulated wave may be represented as mt cos square omega ct plus minus m suffix ht sin omega ct into cos omega ct. At the process of generation process, by using phase shift method, we already discussed the SSB-SC modulated wave, that is nothing but mt cos square omega ct plus minus m suffix ht sin omega ct into cos omega ct. Now the simple multiplication, the SSB-SC modulated wave with cos omega ct, and the outcomes will be mt cos square omega ct plus minus mst sin omega ct into cos omega ct. Here this equation may be extended in the very next stage, that is the half of mt into 2 cos square omega ct plus minus half of mst into 2 sin omega ct into cos omega ct. Here it is very clear that we can apply two basic trigonometrical formula. One of them the 2 cos square theta and another is 2 sin theta cos theta. And by applying 2 cos square theta, we can get 1 plus 2 cos theta, and by applying 2 sin theta cos theta, we can get sin 2 theta, or 2 sin a cos a equal to 2 sin a, the same thing. Okay. Now just apply two important mathematical formula, 2 cos square theta and 2 sin theta cos theta, and after applying this basic formula, we can get E suffix dt equal to half of mt 1 plus cos 2 omega ct plus minus half of m suffix st into sin 2 omega ct, and then the simple multiplication. Simple multiplication means that is half of mt into 1, that is the half of mt, then half of mt into cos 2 omega ct, that is the half of mt cos 2 omega ct, then from the next stage plus minus half of mst into sin 2 omega ct. Here this equation is summation of three components. First one is the half of mt, and the second one half of mt cos 2 omega ct, and the third portion is plus minus half of mst into sin 2 omega ct. Now it is very interesting that the output of the product modulator is this equation, that is the E suffix dt, and this equation is just the input of a low pass filter. Now what will be happen? Now whenever E suffix dt is passed through a low pass filter, then what will be happen? Then the terms centered about plus minus 2 omega c, mind it, plus minus 2 omega c, that is the third portion of this equation, and the second portion 2 cos omega ct and sin 2 omega ct, second and third portion of the last equation, that is the centered at plus minus 2 omega c, that is the high frequency signal, okay, are filtered, and as a result the output of the low pass filter will be able to get the simple message signal or baseband signal in terms of E0. So what is the function of a low pass filter? The function of low pass filter will just suppress the low frequency component that is centered about the plus minus 2 omega c, So high frequency component is suppressed by the low pass filter, and as a result we will be able to recover the original message or baseband signal from the SSBSC modulated wave, and that is represented as E suffix 0t equal to half of mt, and all other high frequency component is suppressed or filtered out by the low pass filter, and that is all about the detection of SSB SE signal by using synchronous or coherent detection. At first we go through the block diagram, and then depending upon the block diagram, mathematically we established our logic, and it is very important in the sense that the equation is very simple, but the two mathematical formula is involved. One is the 2 cos theta, and another one is the 2 sin theta cos theta, and by applying these two mathematical equation, we'll find out the our destination, that means our desirable signal mt from the modulated wave. Okay, it is very simple, and go through the process. If there is any doubt or any query, you just can contact me by phone or mail or WhatsApp, and go through the topic. Okay, all the best. Thank you.